When installing a 240 volts hot water heater, it's essential to adhere to the National Electrical Code, or NEC, to ensure safety and prevent electrical hazards. The primary concern is voltage drop, which occurs when the voltage at the end of a long wire run is lower than the voltage at the source. According to the NEC, the maximum allowable voltage drop for a branch circuit feeding a water heater is 3%. To determine the appropriate wire size, you need to calculate the voltage drop based on the wire gauge, amperage, and distance. The formula for voltage drop is voltage drop equals line resistance multiplied by amperage multiplied by line length. Let's consider a scenario where the hot water heater is 80 feet away from the breaker box. The hot water heater is rated at 4,500 watts and operating at 240 volts. The current draw is approximately 23.75 amps. If you were to use a number 10 gauge wire, it has a resistance of approximately 0.58 ohms per foot. Therefore, the voltage drop would be calculated as follows. Voltage drop equals 0.58 ohms per foot multiplied by 23.75 amps multiplied by 80 feet, which equals 11.48 volts. To determine the percentage voltage drop, you divide the voltage drop by the line voltage and multiply by 100%. In this case, the percentage voltage drop would be 11.48 volts divided by 240 volts multiplied by 100%, which equals 4.8%. Since the calculated percentage voltage drop of 4.8% exceeds the NEC maximum allowable voltage drop of 3%, a number 10 gauge wire with a 30 amp breaker is not suitable for this application. Using a number 10 gauge wire will result in excessive voltage drop, which can cause the water heater to operate inefficiently and potentially damage the heating elements. A larger wire size is needed to reduce the voltage drop and ensure code compliance. A number 8 gauge wire is a better option, as it has a lower resistance than a number 10 gauge wire. With a number 8 gauge wire, the voltage drop would be calculated as follows. The resistance of a number 8 gauge wire is approximately 0.355 ohms per foot. Voltage drop equals 0.355 ohms per foot multiplied by 23.75 amps multiplied by 80 feet, which equals 6.76 volts. The percentage voltage drop would be 6.76 volts divided by 240 volts multiplied by 100%, which equals 2.8%. Since the calculated percentage voltage drop of 2.8% is below the NEC maximum allowable voltage drop of 3%, a number 8 gauge wire is suitable for this application. When using a number 8 gauge wire, it's recommended to use a 40 amp breaker to provide adequate protection for the circuit. It's crucial to consult the NEC tables for ampacity ratings to ensure that the wire size is appropriate for the breaker size. The NEC provides tables that list the allowable ampacities for different wire sizes based on their insulation type and installation method. Firstly, use the correct wire size based on the calculated voltage drop and NEC requirements. Secondly, ensure that the wire is properly insulated and protected from physical damage. Thirdly, use the appropriate size breaker to protect the circuit from overloads and short circuits. Fourthly, make sure that all connections are tight and secure to prevent loose connections, which can cause overheating and electrical fires. Fifthly, follow all local electrical codes and regulations in addition to the NEC requirements. Ignoring these codes can result in fines or legal penalties. Sixthly, if you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation. Working with electricity can be dangerous, and it's important to take all necessary precautions to prevent electrical shock or fire. Always turn off the power at the breaker before working on any electrical circuits. Use appropriate safety gear, such as insulated gloves and safety glasses. Double-check all connections before turning the power back on. In conclusion, using a number 8 gauge wire with a 40 amp breaker is the recommended solution for a 50-gallon hot water heater located 80 feet away from the breaker box. This will ensure that the voltage drop is within the NEC allowable limits and that the water heater operates safely and efficiently. Remember to always consult the NEC and local electrical codes to ensure compliance with all applicable regulations.